Hello and welcome to the lecture series in SageMath that I am starting today. I am planning to cover basics ideas in SageMath in this lecture series, and hopefully that could be useful for most of the undergraduate students and beginners in SageMath. This lecture series is designed in such a way that this could be suitable for the BSc semester 5 mathematics students in the University of Kerala, and I will be mostly following the syllabus for that particular course. The schedule of the lectures will be something like 3 to 4 lectures every week of duration 30 to 45 minutes, and hopefully we will be able to cover most of the basics in around 15-20 lectures. To get the updates about the lecture series, to know the schedule and all these things, you may either subscribe to my YouTube channel or fill the registration form available in my personal website to join the SageMath mailing list I will be maintaining for this course. My personal website link is given here. You can see that. You may of course do both. I will be sending the worksheet and problem sheets through a mailing list that I have just mentioned to the list of people who are registering at this using this registration form. Welcome once again to the lecture series in SageMath, and hope that you will be able to get the best out of it. Welcome once again. Before working in SageMath, I would like to give an introduction to SageMath, its history, its features, etc. So, SageMath falls under the category of a mathematical software, and a mathematical software we mean an application software which is used for solving certain types of mathematical problems. So, one simple example could be a calculator that we usually use for our day-to-day purposes. And advanced mathematical software can solve various types of symbolic computations, and they may help us to visualize various concepts in mathematics by plotting beautiful graphs and detailed diagrams, plotting data, etc. in various styles. Some examples of mathematical software include MATLAB, which is mainly used by engineering students and engineers. Mathematica, Magma, Maple, these are all mathematical software. And GeoGebra, which is a plotting software, very famous. And SageMath, free and open source software. Zylab, again another free and open source software. Parry. And the difference between the software that we saw in the previous page is that the software MATLAB, Mathematica, Magma, Maple are all commercial software, and you are supposed to purchase these things, which is going to be almost impossible for the students, especially because of the huge license fee that one may have to pay. But the software like GeoGebra, SageMath, Zylab, Parry, etc. are all free as well as open source. So this is actually an advantage over the previously mentioned commercial ones. Of course, we are going to focus on SageMath software, and we are going to see that how to handle this software effectively. Some features of SageMath, that word Sage comes from System for Algebra and Geometry Experimentation. It has many features, and it covers many areas in mathematics. It can perform computations in many areas in mathematics, including abstract algebra, combinatorics, numerical mathematics, number theory, calculus, etc. And the first edition of Sage came in 2005, and now in July 2020 it is in its 9th edition. Initially it was created with the aim of creating an open source alternative to the commercial softwares which we mentioned. But what happened after that is that instead of saying that this is an alternative to Mathematica, Magma, Maple, etc., the SageMath itself became very popular and very useful. And people actually started forgetting that SageMath was created for either imitating the features or just mimicking the features in such a way that we will get an open source free software that has all the facilities of Mathematica, MATLAB, etc. But now SageMath has become, at least in some areas, much more powerful than Mathematica, Maple, Magma, etc. The originator, leader of the SageMath project is a number theorist, a mathematician called William Stein. And the backbone of the SageMath that software is the Python programming language, which is a robust and popular scientific programming language employed by many scientific processing units and scientific laboratories, etc. And of course, Google, the famous software giant Google, is one of the main users of this Python software. SageMath is built on the top of many existing open source packages. One aim of SageMath was to club all the available software having different features and combine them and bring them everything into one single platform. Some of the software packages that are used in SageMath are numerical Python, scientific Python, matplotlib, symbolic Python, and staff for statistics R, Maxima, Gap, etc. So SageMath actually includes all these things in SageMath package. And if you want to see the list of software bundled in SageMath, there is a huge list. You may probably try to visit this website, downloads, links, components web page in the SageMath website. So if you like to see a pictorial representation of the philosophy of SageMath, it is this. So it is a car, the parts of which are several other software packages which are already available, free, open source. So the philosophy of SageMath is not to reinvent everything that is already done. Instead of that, combine everything and make a big car. Instead of trying to create the wheel, trying to produce the wheel and steering again and again, the steering is available somewhere, the wheel is available somewhere. You mix them up and make a beautiful car. So this picture credit is to Martin Albrecht, and this website, this picture is taken from the website nialljohnson.net. So how to get SageMath? That's an important thing. SageMath is available for almost all major operating systems like Windows, most of the Linux variants, Apple. And in Ubuntu 18.04 or above, getting SageMath is quite easy if you are connected to internet and if you have very good bandwidth. So run these two commands and SageMath will be automatically installed into your Ubuntu or Mint system. Now, in most of the modern Linux operating systems, if you are not interested in going through the command line, you can go to the software manager and you may search for SageMath and that will be available there. You just select it and click on some install button and it will be done within a few minutes. Of course, it depends upon your bandwidth. To download it in some other way, and if you want to see that what are the other alternate download methods available, you please visit this SageMath website and the downloads page. For Windows up to version 8, it seems that it was a little bit difficult to get it work in Windows, but now version 9 is of course available to install as an executable file, and you may please visit this GIT hub page for getting the installable copy in Windows. Now, how to run SageMath? To start SageMath, what we usually do is we will just go to the applications menu or the start menu, whatever it is, and we will search for SageMath and we can find an icon for SageMath there. Click on that icon and a window like SageMath Jupyter Notebook will be opening in the browser. The browser means Firefox. It can be Chrome, it can be Microsoft Edge, etc., depending upon your operating system and chosen default browser. In Linux systems, probably you may run the command sage -n Jupyter in the terminal, and this may be actually necessary for some older versions of SageMath because the Jupyter notebook style was being employed by default after in the newer versions of Sage only, and if you are having an old version of Sage, you may have to go to the terminal and issue the command sage -n Jupyter in Linux. So you have to type the command like this and you have to press the enter key. And as I told previously, the SageMath software will open in the browser after issuing this command. Now the SageMath window after opening in the browser looks like this. Initially, you will see some Jupyter appearing on the top and all the directories in the operating system just below that. So to run SageMath commands, you may have to create a new SageMath worksheet that I will be explaining how to do that. And then in the input box available, we have to type the command and then press Shift Enter. That means hold the Shift key and then press the Enter key. That whatever SageMath command you are entering there, typing there, that will be automatically executed and result will be shown. Now, if you want to run it online without installing SageMath in your local PC due to some reason, there are actually two ways. One way is to use CoCalc, that is a web-based cloud computing and course management platform, and SageMath is also available in CoCalc. There are free accounts as well as paid accounts, and you may opt for free account and see whether it's suitable for you. This CoCalc was previously named as SageMath Cloud. Now its name is CoCalc. This CoCalc is actually a part of the Sage project and supports editing Sage worksheets and LaTeX files, etc. So the CoCalc website is something looking like this. Now, a simpler way compared to CoCalc is to use SageMath Cell, which is an open source project, and that gives a web interface for entering SageMath commands. So any computation using SageMath can be performed in one cell available in the website sagecell.sagemath.org, and the website input box looks like this. If you enter some command into this input box and press Shift Enter, that command will be evaluated. But of course, there are a few disadvantages if you are using a SageMath Cell or CoCalc instead of installing it in your local system. So I suggest that you try to install this SageMath in your local system, and that will be the most convenient thing to learn SageMath instead of trying to use it online. But of course, if you are trying to learn SageMath using your mobile device, there is no other way other than using either SageMath Cell or CoCalc. Now, after explaining all these basics, we are straight away going into try our luck in the SageMath software, and we will be going in the hands-on training mode. It's better if you just keep another browser window open so that you can try SageMath commands that I'm explaining, and we are going to do that now. To start the SageMath software installed in my local system, I am going to the Start menu or Applications menu and searching for SageMath. I can see it here. So SageMath is here. So it starts like this, and the Jupyter notebook is opening in my Firefox browser, and I'm seeing a window like this. I'm just maximizing, increasing the font size slightly. So you can see that the word Jupyter appears on the top. It means that we are running a Jupyter notebook for using SageMath software, and you need not worry about the technicalities behind Jupyter notebook and all these things. Now, to work, we need to open a new Jupyter notebook. This is only a Jupyter window. We have to open a new Jupyter SageMath worksheet. For that, click on the new button here, and you can see SageMath 9.0 option here. And there are several other options, of course, but we are going to use this SageMath 9.0. But of course, depending upon the version of SageMath installed in your local PC, this number may change. It may not be SageMath 9.0, it may be 8.5, 8.0, etc. Don't worry about these things. So I'm just clicking on SageMath 9.0, and a new window opens up. And here, see that to the right of Jupyter, we can see that untitled is there. That means that the worksheet is not named. We are yet to give any title for the worksheet. I'm just giving the title as introduction. Of course, you can give whatever title you feel like. Just rename. Now, to type SageMath commands, we have to click inside the input box to the right of this IN symbol, and I am just typing some very simple mathematics commands, very simple mathematical arithmetic. I'm just trying to add two numbers, 5 plus 2, and then either I can click on the run icon here. So I'm clicking on the run icon here. So the output is coming as 7, or I can just type 5 plus 2 and press Shift Enter. So if I'm pressing Shift Enter, then also the result appears, same result. But see that the input is named here as input 1 and the output is named here as output 1. Input after that it's input 2, after that output is output 2, etc. These labeling are also going to be useful for us. We will see that in which way we are going to use it later. Now, what about the other arithmetical operators? All the arithmetical operators are supported in SageMath, like 5 minus 2 if I am entering and pressing Shift Enter. 3, 5 star 2, which is for multiplying 5 and 2, and plus shift enter, I will get 10. Now 5 by 2, if I press shift enter, I am getting, oh, that is very strange, 5 by 2 only. And once you understand the features of Sage, this is not actually very surprising. SageMath tries to represent numbers in utmost accuracy in whenever possible. Remember that a rational number is always having more accuracy compared to their decimal representations. Therefore, Sage will keep rational number format as much as possible, and if we ask explicitly to convert that into decimal form, then only it will convert rational to decimal form. For converting this rational to decimal form, we are going to ask SageMath to provide the numerical approximation using the n command. So n of 5 by 2 and one bracket open, one bracket closed. So shift enter, that gives 2.500, etc. So this n stands for numerical approximation, and we can use the long command also. Capital N is a short form. If I type NUMIRI and press the tab key, then I will see all options in all commands in SageMath that are starting with this NUMERI, and I am choosing this numerical approx. Then I am typing the same 2 by 5. I am getting, and shift enter, I am getting exactly, oh sorry, instead of 5 by 2 I typed 2 by 5 or numeric approx. 5 by 2, I am getting 2.5 exactly. So this n of, that is actually a way to get the decimal representation of any rational number. Now we have division that's done. Now we have the exponentiation operator. 5 to the power 2 is 5 hat 2, that is equal to 25, and instead of 5 hat 2, one may also equally use 5 double star 2. Double star is also, star is also the exponentiation operator in Sage. So if I press shift enter, again I'm getting the same result. Now one more operator is there, that is the remainder operator. If I type 5%2, I will be getting 1. Remainder, just remember that using, if we use the division theorem, we know that we can write 5 is equal to 2 into 2 plus 1, and that 1 is the remainder, and Sage is giving 1 back to us. So all kinds of arithmetic is supported in SageMath. Of course, we can have 5.2 real number arithmetic, decimal arithmetic is also possible. 5.2 plus 5, that gives 10.2, etc. And another thing is, instead of trying 5 by 2, if you want to get the numerical approximation directly, you may also try 5.0 by 2. So that also will be 2.5, because Sage understands that you are using a decimal representation and you actually want decimal representation. Therefore, Sage will convert both these two real numbers instead of treating them as rational numbers, and then the result will be also a decimally represented real number. So these are the basic arithmetic operators available in Sage. Now, there are all kinds of mathematical constants are also available in Sage, like pi, e, etc. For example, suppose that we want to see the numerical value of pi. Numerical value of pi is n of pi, that is going to be equal to shift enter, so 3.14, etc. And the number of digits is determined by Sage by because there is a default number of digits to show after the decimal place in the numerical approximation function. We will see how to change the default number of digits and all these things later. Now the number e, the constant e, that is also available in SageMath, and its name is just e. So n of e is 2.71, etc. Of course, we can perform arithmetic also. E square, n of e square, that is equal to 7.3, etc. Now instead of suppose that we are trying to find out the area of a circle which has radius equal to 2, then we can just find the area like pi star r at 2, pi r square, and sorry, r we cannot give because r we don't know exactly what it is. That's a formula. Pi 3 square, that means area of a circle with radius equal to 3, and the result is 9 pi, because Sage is not willing to convert that pi into decimal form, because while converting pi into decimal form, the accuracy will be losing. So instead of that, we may just copy this and try to find the numerical approximation in this way. So numerical approximation of pi star 3 to the power 2, and that is nothing but 28.27, etc. So the mathematical constants are also available there in SageMath, and you can straight away use that without any importing or defining the constants. It's already available there. Now we are going to see how to execute all these commands in SageMath Cell server if you do not have a locally installed SageMath software. So I am just trying to see a SageMath Cell in Google, and the search results in this link, SageMath Cell, Sage Cell server. I am clicking on that, and the input window comes here. I'm just typing n of, okay, let me increase the font size, n of 5/2, and then I'm clicking on evaluate. Of course, you can press shift enter also. If I click on evaluate, the output comes here, but after some time, it's not that fast as the installation in the local machine. So output comes here, but the difference between a locally installed Jupyter notebook and SageMath Cell, Sage Cell server, is that there is only one input box available. So if you want to try one more command, you may have to remove this command, then you have to type the new command. That's the difficulty here. So let us try what is n of e square. So for finding n of e square, we need to remove the already typed command. Then I'm pressing shift enter and coming down. That is 7.38. What about here? 7.38, etc. So the answers are exactly the same, but the only difference is that you will not be able to perform computations in a sequence in different input boxes. You have only one input box available. But of course, for practicing purposes, that may be sufficient. But when we are trying to perform function definitions and long computations, this is going to be a big disadvantage. Probably you should try to create an account in CoCalc, and there you can create SageMath Jupyter notebook like this. To find the square root of a number, one may either use the square root command, the square root of 25, sqrt, press shift enter to get 5, or sqrt of 10, that is equal to, oh, that's the problem, is that whenever Sage sees that the result is a non-rational number in the decimal form, so it keeps that number in the original form itself without converting that to numerical approximation directly. So we will try n of square root 10, and the value is this. And or otherwise, one may actually try 10 to the power 0.5 to get square root of 10. This is also possible. Directly also one can evaluate that. Or in fact, even 10 to the power 1/2 also should work exactly in the same way. And see that here 10 is an integer that's in the rational form. 1/2 is also a rational number. Therefore, Sage is not converting that rational to the power rational to decimal form. It simply keeps the square root of 10 format, so that the accuracy will be much more. So if we want to convert that, again we have to apply the numerical approximation function here. Now, but we know that in mathematics, we know that square root of 10 or square root of 25 is not just one number. It's actually a pair of numbers are there, because negative and positive roots are there. To see all roots, we can give an extra parameter like all equal to true in the square root function in the following way. Square root of 25 all equal to true. That means that we want all roots, not just one positive root. Otherwise, Sage will be giving only the positive root. And if we evaluate, we get the roots to be 5 and -5. So all equal to true is the key here to get all the square roots. Now, in a similar way, the function logarithm function also we can use. Logarithm function is log of course, it is to the base e. So log of e is equal to 1, because log means that natural logarithm. Of course, you can use ln of e also, and that also will give 1. But if you want to use some other base other than e, but log function one may have to use. For example, suppose that logarithm of 100 to the base 10. So that is equal to, so the command, the structure of the log command is, so to write comments we have to use the hash symbol, logarithm number base. This is the standard format. If you are skipping the base will be by default assumed to be the exponential, the constant e. Now the trigonometric functions also have their usual names, like sine of pi by 2 equal to 1. But remember that the trigonometric functions are expecting their arguments in radians. So if you are trying to give degrees, you may get some unexpected results. So to avoid that, you may try sine. If you are giving degree, you have to convert it to radians using the math.radian radians function. So convert degree to radians using math.radians, and oh, that's wrong, math, and the result is 1.0. And of course, to convert back to degree, math.degree of pi, if one tries, you can see this is not degree, this is degrees. Yeah, if we try math.degrees function available in SageMath, we can see that pi converted degrees is 180. So while using trigonometric functions, one has to be really careful to use radian arguments in the unit radians. So just like that, cos of pi by 3, that's equal to 1 by 2. Cosec, everything is there. Now to find the inverse of trigonometric functions, one have to use arc sine of 1, and it gives the least value, and the value in 0, 360, the first possible value it gives is 1 by 2 pi. Arc cos of 1 by 2 is arc cos of 1 by 2 is 1 by 3 pi, and so on like that. So trigonometric functions also can be used as we usually do in a mathematics notebook. That's why we call a Sage Jupyter notebook, because we can write whatever mathematical expression, whatever mathematical formula that we usually write, exactly in the same way we can write even here. Now one may even define functions here, our own functions here, using the def command, def of f of x. Suppose that we define to be return x square or x square by 10. Suppose that we are defining it like this. This is a function definition. So what is f of 10? The answer is 10, because 10 square by 10. We can define our own functions like this. Otherwise, define g of x in the following way: sine of math.radians of x plus cos of math.radians of x. So we have to return this and press enter here. One space is required here. Now press enter here. Now what is g of 90? So g of 90 is given to be equal to 1, because sine 90 is 1 and cos 90 is 0. So we can define our own functions also in this way. So these are the basic things about SageMath Arithmetic. We have tried all basic arithmetical functions. We have tried how to use trigonometric functions. We have seen how to use the logarithmic function, the exponential function, etc. And we can try, of course, all these things in the SageMath cell server also. So I'm just copying and pasting that command here. So if I copy paste r cos 1 by 2 and try to evaluate, the result is exactly the same. And let me try one more command. I'm defining this here. So copied and pasted and evaluate 1.0. So Sage Cell Server also works exactly the same way a Jupyter Notebook will work. But the issue is that you cannot try too many commands, and if you want to try a different command other than the one that you have already executed, you may have to delete the previous command and start over. That's the only difficulty here. Otherwise, SageMath Cell, Sage Cell Server also one can use for their computation. And probably we will be stopping our first session on SageMath with this, and we will be continuing with more topics in the next session. And thank you very much for your patient listen. Thank you.